Let me just introduce you for a second. So Ron Lockwood has just finished his, what is it, a doctoral program?
Master's.
A master's program, and as part of his master's program, he was working on some of the automated translation ideas in the context of our tools. So he's going to present what he did and what he's learned here. So thank you, Ron, for agreeing to do this. We're putting him on a different day than normally I would have, but this is the only time he had an opportunity to do it.
Yeah, thanks, Mike. Yeah, I'm going to be gone the rest of the week, so thanks for squeezing me in here, and thanks for the privilege of presenting to all of you.
Das ist der Mann, das ist jetzt so einer, der wie ich halt da einzeln teilnimmt. Verstehst du?
Rechts.
Ja, hier. Der macht jetzt.
Background noise.
Der macht jetzt den Vortrag.
There we go. Thank you. So, yeah, let me just share my screen, and we'll get to the presentation here. I have the chat window open, so I guess you can communicate to me with questions that way, if you'd like. And you should be seeing my presentation now. So let me just give you a little background on me. I've been in SIL for, 15, 20 years, I guess, when you include my training. So I come out of a background of having a math degree and worked in the computer industry as a software engineer, and then worked on a language project doing translation here in Germany, where I'm located now. And as Mike said, I just recently did a master's degree in computational linguistics, and so my focus for my thesis was seeing what we could do for something like a Carla system for today's day using Flex. So I came up with this system called FLEXTrans, and I want to present it to you today. Now, some of you have already seen this, so sorry for that. For some of you have seen it already. There's a couple additional things that are new, so you don't have to totally fall asleep. But, so what's the problem we have today? The issue is that low-resource languages, like the ones we are often working with in SIL, are kind of left out of this whole machine translation revolution. And the reason is there's not sufficient text data to do what's called statistical machine translation. To do statistical machine translation, you need lots of data and parallel texts, and the more data, the better your results. So you kind of have to use a different approach, a transfer-based approach. And so I looked around, did some research of what is out there right now for doing machine translation using a rule-based system, kind of writing rules to do the machine translation. And most of the systems are too complex or too specialized, or there's a lot of statistical needs built into those, even though they're not supposed to technically be that. So I proposed a solution, and I'm calling it FLEXTrans. And it's a transfer-based system that I'm calling linguist-friendly. So I wanted it to be usable for our linguists in the field. And I'm saying it's linguist-friendly because it uses Flex as the core, which is a nice graphical user interface for the repository of all of your linguistic data. And it also used some well-documented tools such as Apertium and Stamp, which I'll tell you about. You can still kind of use the stealth to wealth approach that we've talked about in SIL, where you can start simple and get more complex. And I think with some training, linguists can really do this machine translation with FLEXTrans. And this could be the breakthrough that we've been looking for, or at least something to build on for more and more things we want to do with automatic translation. So here's a diagram of kind of what the system looks like. You've got Flex project on each side. One is the source and one is the target. And you, of course, have a lexicon and text in each side. and grammar comes into it, especially on the source side, but also a little bit on the target side. And there's three main processes that you go through in a transfer-based system. You analyze the input text, then you transform it into morphemes in the target language, and you do that using tools like the Bilingual Lexicon and a set of transfer rules that show you how the language gets rearranged. And then as a last step, you put the pieces back together and synthesize it into a text that's in the target language. So what part is what? I'm putting together three different tools to accomplish this. So Flex is represented by the colored boxes you see here. This tool called Apertium does the middle section, the transforming of the text. And then Stamp does the synthesis part that comes kind of at the end of the process. I don't need to tell you much about Flex. This is just a slide about that. Let me tell you a little bit about Apertium. It's been around for, I don't know, 15 years at least. And it's an open source transfer-based system, and 40 language pairs are already on it. It was developed in Spain and has a lot of power and is actually used in real situations. Universities use it for translating, and there's a web front end. You can go check it out, and it's got this key component, a powerful shallow and transfer-based engine, which I'm including into my system, and I think it makes it really good. Now, the last tool that I'm using is Stamp, and many of you may know about Stamp. It's part of the Carla machine translation system that was done quite a while ago. And the key thing here is I'm using the synthesis component that is compatible with Flex, so it works out very nicely. So there's some things you have to set up even before you kind of get going in machine translation. And this is just a list of some of those things. You need lexicons, you need grammar settings, at least a minimal amount. The more grammar you put into it, the better it's going to be. You need to link your lexicon word senses. So you need to know that this word maps to that word in the other language. And then, of course, you need transfer rules. That's a key component of how the language gets transformed. So I'm going to walk through a English to Swedish example as we talk here. And we're going to just see how an English sentence like this turns into a Swedish sentence like this. So I guess you can save up your questions to the end. I guess I don't mind if you interrupt with some questions along the way, but I guess I just need to hear them when you interject them or put it in the chat. Otherwise, you can save them toward the end. I'll leave some time at the end. So we're going to walk through a little bit of each of these pieces. So analyzing the source text is the first part. And you can either do it manually or automatically, and this is all done in Flex. Then if you're familiar with the interlinear view in Flex at all, you can approve all the words. And that's a kind of a necessary step there. This is what it looks like after you've approved all the words in your text. There's no blue or orange boxes, which are sometimes there when you're first doing it. So having the analyzed text is the first kind of prerequisite. I also wanted to mention that there's a configuration file where you set different things like the name of the text that you're working on that you want to translate, what the target project is, and a bunch of other settings. That's just a text file. So we also said we needed links between the various words. So in our example, we need links between these three words. We don't need a link between man and man because it's spelled the same. It'll just transfer over automatically. And then we don't need a link for the word the because in Swedish they don't have the word the. Now how does the linking work? what I've set up is requirement for 2 custom fields in your Flex entries, and the target equivalent that I have showing here, it could be called anything, but that's what I've called it. It has a URL link to the entries in the other project. So what's on the right side represents the Swedish project, okay? And we have links to the Swedish project from each sense on the English side. And the key thing there is that there's a GUID so that I can, find it in the other project. Now you can do these links manually. If I just go back here again, you can do them manually just by doing the copy as hyperlink, paste as hyperlink operation in Flex, if you're familiar with that at all. But that gets a little time-consuming to do it for a lot of entries. So I created this linking tool, and it'll help you link the words between lexicons. So I just wanted to show that live demo of that, which I know is very dangerous to try a live demo, but let's see if it works. So this window you see here is Flex Tools, and this is something that Craig Farrow developed, and it's a very nice environment where you can run Python scripts against the Flex database of your choice. And here's one module that I have in here, and this is the linker tool. So I'm going to run it, and I run it in modify mode because it's going to change one of the databases. All right, so it's examining both databases, both lexicons, and then comes up with kind of a little list of all the entries that need to be linked in a particular text that I'd set up in my configuration file. So you can see that they match on gloss. So if the gloss is the same, then it puts a row into this table. And then I have one already there for the ones that you're linking, but you can change those to zeros if you don't want to link it. Eventually this will be a checkbox. You notice there's 2 words for book. There's book as a noun and book as a verb. So it automatically did not link the book noun on the English side to the book that's a verb on the Swedish side, because you probably don't want to link a noun to a verb like that. But the one that is where they're both nouns, it did automatically give me a 1. So once I click OK, it's going to go through the Flex database and make those entries, those URLs, get pasted into each of those entries. So that's the tool to do that. So it just kind of speeds up the process. Now, that kind of gets our initial setup kind of complete, and then the actual modules that I wrote for FLEXTrans, and Apertium comes into it as well, get done next. And it's a 3 kind of step process. You run 2 Flex Tools modules, then Apertium, then 4 more modules. So I'll just go through this kind of quickly to give you an idea. Okay, first you have to extract the analyzed text. So what you did in Flex has to be pulled out, and it has to be pulled out in a format that Apertium can read. So that's what this module does. Apertium is used to working with text files, so the first module does that. Also, you need to extract a bilingual lexicon, and that comes out of the links that we just talked about creating. And that comes out as an XML file, which Apertium needs in its transfer process. And just to show you how you actually run these modules, I'm going to show you that. So here's Flex Tools with all of my modules that I'm using. So I could run the first one, for example, to extract the source text. It's opening the source text. It exports 6 analyses and puts them in a particular file. Then I can extract the bilingual lexicon. Run that module, and it goes through. It takes a little longer because it's dumping out something for every entry in the English dictionary. So it did 5,000 entries. And now we've done that part. So kind of our step one is done. So what actually happened behind the scenes? Just wanted to show you a little bit under the hood what happens here. Things get dumped out to this text file kind of format. And just to illustrate what one of these words looks like in this format, it's called Apertium's data stream format. You know, different pieces mean different things. You have the start of the lexical unit, end of the lexical unit, and then sense information is in there, the grammatical category, and any number of suffixes could also be in there. Then when we talked about the links, what actually happened when we ran that module to create the bilingual lexicon? I wanted to show you that. So here you can see an XML kind of format. Excuse me as I drink a little bit. So on the left side, we have the English word, and on the right side, the Swedish word. And you can see that they're bracketed in a left element and a right element. Similarly, for the verb, it looks like this. It's a little more interesting to look at the noun apple because it's got some extra information. As part of it, has a for and a newt in there. Those are inflection information that get put in there that comes out of the Flex dictionary as well. And this is kind of an illustration of that. The Swedish entry Äpple has fourth declension, so that's an inflection class, and it has neuter gender. So those things get dumped into the bilingual lexicon file. Because that's very useful information as you're writing your transfer rules. You want to know if something's neuter or certain declension so you can make the appropriate adjustments. For the word man, what comes out is just like this, an identity. Left and right are the same, so it just puts it in an I element. So nothing really has to be done. So then the next step is to run the Apertium tools. And the Apertium tools take as input that, of course, the text that got created to this point, the bilingual lexicon, and transfer rules. It does the lexical substitution and applies the rules to transform what came in into Swedish morphemes. So we looked at the analyzed text and the bilingual lexicon. Let's look at the transfer rules a little bit. Remember, our goal looks like this. So from a linguistic perspective, we need to do some special things for the verb takes and for the noun apple, the apple, because that needs to be condensed into a Swedish word with an extra suffix. So to do this, we need two rules, a verb rule and a noun rule. So just a quick diagram of what that looks like. We basically remove the English suffix and we add two Swedish suffixes, and then the lexical substitution just kind of comes across from the bilingual lexicon and Apertium's job that it does there. So what does that look like in terms of the actual rule that gets written? Well, the rules are written in an XML format, and it looks something like this. You've got two main parts of the rule. You've got the pattern, and you've got the action. So if something coming in the input stream, some of the words that are coming in match the pattern, in this case a verb, then we're going to go ahead and do the action. And the action says output something. That's the next element down that you see. And then the LU stands for put out a lexical unit, so it's going to put it in between a caret and a $sign to indicate this is a lexical unit. and I'm going to one by one put out the things that you decide to put out. So in this case, we're putting out the lemma. So that's basically the Swedish translation of the English take. And then puts out the grammatical category. And you'll notice the TL here. That means target language. I want to pull things from the target language part of the bilingual lexicon. And then I'm going to put out two tags, which end up being suffixes, an infinitive tag and an indefinite tag. So those end up being suffixes that will match the Swedish lexicon. And the third singular totally went away. It's not even needed in the Swedish side. And that's the rule. Now this is what it looks like in a nice, friendly XML editor, which is what our linguist would operate with. But I did want to show you, what it looks like under the hood, XML-wise. But having linguists edit this would be a little bit painful for them, I think. So this, we were setting this up with Andy Black's help to do it kind of like Xling paper does it. And so you just have things to fill in the spaces, and you can click on radio buttons and check boxes and things like that. And there's data integrity checks as well. Are you putting in something that's legal for a pattern item or for a part? So that works pretty nicely. Okay, just to go through quickly the noun rule, similar kind of process. You need to write the rule. And in this case, we're removing a word completely, and we're adding a suffix. What does that look like in the XML? Again, we match a pattern, but in this case, it's a two-word pattern. Okay. And because it's a two-word pattern, you see down here we're using position 2. The last one I didn't tell you is position 1, because there was only one item in the pattern. But we don't care about the thing in position 1 because the goes away. So it makes a match on the two items coming in, the input. Because of that, it's going to run the action. First thing it does is it calls a macro. And this is a macro that just sets a variable. Depending on what declension this word is, it's going to set the definite singular variable, which we see down below, to the appropriate thing. So it's a little bit like writing code. This macro just kind of extracts it so it's modularized, and you can use this kind of same logic in other places. It's got some if-then logic in there. We do the output again. We get the lemma. We get the part of speech. We get this contents of this variable outputted as well. And that's the rule. It turns this input into that output. In the nice-looking XML editor, it looks something like this. Okay. So there's a couple options you have for running Apertium, and one is going to a website, uploading files, and downloading the results. That's kind of was my standard for the beginning part of this whole project. In recent times, I've been able to get a Linux virtual machine running locally that can kind of continuously process any input files. And for this demonstration, I'm using the second option. Of course, this second option, you have to, help the person who wants to do this a little more hands-on to get it all set up. I'll talk about some ideals for the future later on. So the transfer results that we got from the previous thing in Apertium, well, I guess we're looking at the English side. This is what we had for English, and what happened, it got all transferred to the Swedish after the rules were run, after the lexical substitution was done. Now let's look at the last step, the synthesis. Okay, I have several modules that run here, 4 in fact, and it's a lot of housekeeping basically, so that Stamp can get ready and run. So catalog which prefixes are there, then the data stream that came out of Apertium needs to be converted to ANA style records that Stamp can read in SFM kind of format. And then I also need as SFM files the lexicon from the Flex target project. So those are SFM files that get pulled out, so Stamp can use those. Then Stamp needs to be run against those input files. And then as the last step, insert the resulting text into the Flex project. So what does the synthesis side look like, just as an illustration? So here's our Swedish words with our Swedish suffixes. Those get looked up in the Flex database and look something like this. These would be the lexical entries. And then from those entries, the right allomorphs have to be chosen, which, as you notice, in two cases aren't the same as the lexical entries. And then these parts get put together and synthesized. Now, just a word about the allomorph choice. The way this works is, you may have two different forms. Like here we have the T form and we have the ET form. Well, it comes out as ET as the kind of the standard lexical form, but which one actually is the surface form that we want? Well, it has to go through some test checking. So first it looks at all the allomorphs. So we have T as our first allomorph. It checks that. This is going to be a valid suffix for any noun in Swedish if there's a vowel first. And the vowels are made up of these different letters that you see. Since E is one of the vowels in there, then it's going to use this T for the output. And because we had a match on the T, it ignores any other allomorphs that might be below it, and it ignores the lexeme form, which is the elsewhere allomorph. So on the target side, the grammar settings are mainly have to do with setting up your allomorphs and constraining them appropriately. All right, now I'm going to show you how I run the other modules. So the target prefixes is just trivial because there's no prefixes here, but convert the text to Stamp format. Doesn't take too long. I extract the target lexicon, so it's extracting the whole Swedish lexicon. 792 roots extracted. And then I can insert the target text. But what I'm going to do, instead of running them one by one, I'm going to show you how you can run all of them at the same time. And I do it in modify mode because I'm going to update the target text, target project at the end with the target text. So now it's running through all 6 of the different modules. It has a little delay built in there so that the Apertium tools can run. It's using the local Linux server, and now it's finished. Now you noticed on this second to last module it said skipping a sentence. Now one of the things Flex Tools is nice, gives you a nice environment for is I can double click to certain entries to see what the issue was. So I'm going to do that and bring up the Swedish lexicon. Bear with me a moment as that starts up. Okay, it's coming up on my other screen here. And after this refreshes, see that yeah, this indeed did not have any grammatical information, this word, so that's why it skipped it. But what we'd really like to see is what happened to this new text. Did it get put in here? We have to do a refresh, and then we see this text in apple a day. And there it is. That's the translated sentence that got inserted. So we've successfully translated from English to Swedish. Yeah, Andy Black had written a note here a little while ago that I should note that it's a proof of concept tool, and yeah, it's not totally polished, but it is usable in real projects. Let me just go back to the PowerPoint. So I wanted to show some other capabilities of this, kind of some built-in features that are in the modules, the Python scripts. And then at the end, I want to share some of the future developments and how this might get rolled into Flex. So variant forms. Variant forms are things we deal with in every text. And they come in all shapes and sizes: spelling variants, dialect variants, free variants, flexional variants. So in FLEXTrans, it helps do this whole process by not having to worry about every single variant. Since all the variants have a main entry, we just deal with the main entries. It looks something like that. Say you have color spelled this way, maybe what we call the British spelling. That is linked to so in the text is linked to this variant entry. That variant entry is linked to a main entry with the spelling C-O-L-O-R, assuming we think that's the primary spelling. And then that is what gets put out in the actual data stream. And so the user doesn't have to worry about making links from all the variant entries and things like that. Now, irregularly inflected variants are a special kind of variant. I wanted to show you how FLEXTrans handles that pretty well. So if we talk about the ed ending, like the word repaired, you see that past is kind of built into ed, but when we have the word took, we know it's past, but there's no kind of overt suffix that shows us that. And when we're translating between two languages, we'd like to transfer the sense information, that tense information in both cases. And FLEXTrans has a way to do that using the variant type. Let me just show you a little diagram of this. So in the normal case, we get repaired because it's analyzed as two morphemes in Flex, comes out as two tags. The verb is one tag and the PST is the suffix. But when we have the situation of took, there's no extra morpheme there to indicate past. So we don't want just take V and then done with it. And here's what FLEXTrans does. It finds took, and took is a variant. And it's a special kind of variant. It's a irregularly inflected variant. It refers back to a main entry, take. So we put out that main information, the main entry, but we also see that this variant type has some special things associated with it. It has some inflection features. And so we take those inflection features and put those out as part of the word. And so it basically looks like a suffix. The target side has kind of a same kind of thing. I won't walk through that, but just it's the reverse that's needed. Now there's things called complex entries, where you have multiple words that make up one kind of linguistic meaning. For example, the word clean up. You know, it's two words, but it has kind of one concept. So you still want to be able to translate between concepts, even if it's a multi-word thing. You still want to translate that concept to something in the target database. And FLEXTrans handles this by looking for adjacent words that are components of a complex entry. And just to illustrate that, let's look at cleans up as an example. So in Flex, it's separated as two words, cleans and up. It has its own cleans up, or clean up as a entry has its own place in the lexicon, and it has two components, clean and up. And so when these two words come together, FLEXTrans knows that what should be put out is one unit and calls it clean up 1.1. So this all comes out of the structure that you have in Flex, makes this possible. The target side is also needed, where you might be translating something that goes to a complex form, and you need to reverse the whole process and break it down. And I won't go into details on that. Another thing is unknown words. FLEXTrans is able to handle unknown words, which you might intentionally not analyze. And this often could happen when you're working with proper nouns. You don't want to put every single proper noun into the Flex dictionary. And so you just, perhaps you're working with two related languages and the spelling of the proper noun is going to be the same in the target language. So you can just let it flow through without modification. And the way this looks in reality is you start out with the word Florida as a sample proper name. It doesn't get any analysis in Flex. And so after you extract the text, it gets an unknown grammatical category. Apertium doesn't really know what to do with it because it can't find it, so it puts an @ sign in front of it. And stamp takes off the grammatical tag. But then after you tell FLEXTrans to clean up these @ signs, you come back with Florida at the end. And that's a setting in the configuration file, so you can either keep the @ signs there for debugging purposes or take them off at the end when you're kind of ready to do a production run. There's a couple more features, custom linking and category mapping, that I'm not going to go into detail, but this gets you some of the flexibility of making custom bilingual entries. And sometimes the category system in one language might not totally match the category system in another language, and you can do kind of wholesale mapping between one and the other. So then as a last step, I wanted to tell you, what's the future development of this? Well, my long-term dream would be basically this whole FLEXTrans system be integrated into Flex. And yeah, it may take some steps along the way to do this. It's not going to happen overnight. But so we might, transition it into Flex over time. And some of the short-term steps to begin with is to create a linking system between Flex projects. And I know that's already kind of on the list to do. But just to be able to support it in such a way that FLEXTrans can still use it. Also, a short-term thing would be able to compile the Apertium tools in Windows. And I probably need some of you smart compiler-type people who know how to compile cross-platform to get it working in Windows, and then we don't have to have this whole Linux box or virtual box there. In the medium term, integrating something like this linker tool would be great to have that in Flex. And then to kind of subsume Stamp and some of its functions into Flex so that you can deal directly with this Flex lexicon and not have to deal with external SFM files. And then things in the longer term are being able to write the rules that are currently XML rules outside of Flex, maybe have a writer built into Flex for that. Creating an analyzed text at the end of the process would be fairly straightforward to do, I think. And doing that would enable kind of a daisy chain process. You go from language A to B, then from B to C, and C to D, where everything is going to a different analyzed text with a different set of rules. That would be possible. Debugging tools would be very helpful along the way, and having test suite capability for regression testing would be very, very helpful as you're doing a whole project to translate from one language to another. So those are the things I've come up with. I'm sure there's a lot more things we could talk about on top of this. But yeah, that's the system, and I guess I'll open it up for questions now.
I have a question.
Right.
Can you write rules to change the order of words?
Can you say it again? I didn't quite get it.
Can you write rules to change the order of words?
Yes. Yes, you can. There's two engines, and I didn't go deep into this. There's a shallow engine and an advanced engine in Apertium. With the shallow engine, it's fairly easy to take 2 or 3 words and reverse orders and things like that. So that's doable. The advanced engine kind of takes it to another level where you can do syntactic switches. So you can come up and find out what the noun phrases are and say, okay, this is the subject noun phrase, and this should be put in another part of the sentence. And I've been experimenting with that and been successful. And the key thing, too, is that this has been successful on major languages in Spain and English to Spanish and other things like this. So they've done major rearrangements that are necessary in those kind of languages.
Ron, this is Bob Eaton from Dallas. I know in the past you were using Ample. Do you feel like, having done this work, that Apertium is a better way to go than Ample?
So actually, Ample is still a key thing there, because it's basically what Flex is doing. Xample is what it's doing. Apertium is the component that's doing the transfer part.
So rather than trans, whatever it was in the Carlos Studio paradigm.
Yeah, we had Centrans, I think. That would help with some of the transfer. Also, Stamp did some of the transfer part.
You're converting back and forth from SFM to the Apertium thing, and I'm just wondering if it was, in hindsight, do you feel that was a good thing to pull out and use instead of Centrans?
Yeah, I felt like Centrans was really too weak. In Centrans, you don't have the if-then logic capability, whereas in this Apertium system you do. You have this concept of macros, and crucially, in Apertium, you can refer to the target side of the bilingual lexicon. Could never do that in Centrans. So there's a lot of power that's really in that transfer engine that you can take advantage of.
The other question I had was, we use Adapted a lot, and primarily because using the Ample approach involved me having to do a lot of work, and I don't like to do a lot of work. And since labor is cheap in India, it's not hard to get them to learn how to use Adapted, which basically just works on the whole word form rather than trying to break it down into morphemes. I'm just wondering if another step or another possible future thing would be avoiding the interlinearization and using, glossing, whole word glossing forms from the source to the target projects. Of course, that would bypass the whole Apertium thing, but I'm just wondering if you had thought about that at all.
Yeah, and I think that's one approach. It kind of depends on who your target audience is. So if your target audience is the mother tongue translator, then you might want to do whole word kind of things and bring some kind of smarts on top of that to figure out what rules can be inferred from what they're doing. My approach is more with the audience being the linguist. So the linguist is working in maybe a multilingual situation, multiple languages going on, and he sees that, okay, with a few linguistic tweaks, we can get from language A to language B, and but the rules have to be kind of linguistically based and run across the whole text. So that's more my target, where you have a linguist there who can write those rules and then apply it, on a large chunk of text. Thanks.
Ron, this is Damien. I have a question.
Sure.
So I'm looking at Apertium, the document for it. And so it looks like, so you're mainly using the structural transfer and the lexical transfer modules in Apertium. Is that correct?
Yeah. Mm-hmm.
Okay. So, and there are all these other modules in there, like the, stuff like, for example, for doing the morphological analysis and then the synthesis on the other side and stuff like that. Have you experimented with any of the rest of Apertium?
Yeah, I did. Earlier in my program, I started creating a language pair and using their analysis system and their generating system, which actually is kind of one and the same. It uses, what do you call it? I can't remember, but yeah, it's a good system, but the problem is you have to deal with text files of lexicons, and you create paradigms and say, okay, this word fits this paradigm, this is how it gets broken down, and you have your whole lexicon in this text file, whereas our linguists have the lexicon in Flex, and that's a much nicer way to work with a lexicon, and you can have so much more richness there. You can have this inflection information there, lots of that stuff. I mean, you could look at perhaps having Flex be the front end that creates this text file for Apertium, but then you have to talk about a different system where you're using paradigms to say what your breakdowns are going to be and things like that. So yeah, it's interesting. Their system is good, but I feel like it's not very user-friendly for somebody working with lexicons.
Right, that makes sense. I just want to mention one other thing that you might not know about. There's a module that is used inside of Flex that can handle those kind of transfer rules that you describe, and it's actually used in the hermit crab parser, and it's also used for the complex concordance tool in Flex. And so I think that might be something that's kind of already integrated in to a certain extent. That could be used to do those kinds of transfer rules that you had Apertium doing. It's just something to look into.
No, I know you've been looking into that, and Hermit Crab being maybe the engine instead of Example for doing some of this stuff. But I come down on the side that it's really too hard for the average linguist to use Hermit Crab. Get all the phonological rules set up, debug that thing. Working with surface forms is a lot more straightforward in my mind for most ordinary linguists. So I went that direction. Now, doesn't mean you couldn't at least on the synthesis side, use Hermit Crab to put things back together. And one project has talked about that with me. So I think there's some things you could pull out and put back in, kind of modularize it. But yeah.
Right. Yeah. I was just saying that the Hermit Crab, there's the module for its rules that could be used also to do like transfer rules. That's all I was mentioning. And the other thing is that Hermit Crab can actually do the same type of, you don't have to define all the, the philological rules and philological features and the phonemes and stuff. It can actually do a similar type of analysis as example does. Anyway,
Yeah.
We can talk more about that later.
Any other questions? I know it's late there.
I have a question, Don from Waxhaw. Does your system allow for ambiguities, like a multiple parse of a verb? Or in your example of clean up, would it allow clean up to be a phrase in one context and separate words in a different context?
Yeah, ambiguity is a good issue to talk about. Yeah, you're always going to have ambiguity, words that could be parsed multiple ways. Maybe as a verb one time, maybe as a noun one time, or even as a noun multiple ways within that. So some approaches are you just throw it all in there and you deal with all the ambiguities at a later stage. By using Flex's system, which is kind of straightforward from one side of things, that the user just says, okay, these are all the parses that I accept. So a word like takes might say have multiple ambiguities, but in your Flex project, the user says, okay, of these three, I'm picking this one, and I say that's the correct one. So you're getting rid of all the ambiguities on the Flex side as you approve the text. Now, as to the cleans up thing, if you're saying cleans up is a complex form, right now my system is always going to see that as a combination of things. So when it sees clean next to up, it's going to say, oh, I've got a complex form, and put it out that way. Yeah, the syntactical ambiguity where up could be connected with something else in the sentence, you'd have to handle that in a transfer rule. Does that answer your question a little bit?
It does, thank you.
Anything else? All right. Thanks for listening.
Thanks, Ron. It's great.
Thank you very much, Ron. Really appreciate you showing us what you've done. It's going to tie into some things that Damien's going to end up talking about tomorrow, I think.
Right.
Go ahead.
I'll have to make sure I get the tape for that.
Yeah, that's true. Okay, so I want to thank everybody for their participation. So concludes day one. Let me just close us with prayer here. Heavenly Father, I thank you for this time that we've had together. I thank you for the fact that the technology has worked for us. I thank you for all the things that you've allowed us to accomplish that we're witnessing. Lord, we are reminded that we're doing things that the enemy doesn't like. And I just pray that you would give us wisdom as we proceed, that you would help us to have that full armor on, that we would pray for each other and encourage each other. And just thank you for the interactions that we've been able to have today. And pray that tomorrow would go well, that you'd help us to continue to move forward in defining what we're going to do into the future and understanding what we've done in the past. In your name I pray, amen.